Welcome back to Cancers 101, the podcast where we uncover the mysteries of cancer biology. I'm your host, Rittika, and today we are talking about organ specific cancers. Why do cancers like pancreatic, breast, lung cancers behave so differently? And how does the context of each organ shape cancer progression? Today, I'm joined by Aditi Dubey, who will help us dive into these questions. Aditi, let's start. Why do certain cancers have organ specific behaviors and molecular signatures?
Great to be here, Ritika. So, the key lies in the microenvironment of each organ. Every tissue has its unique architecture and molecular profile, which shapes how cancer cells grow and spread. For example, breast tissue has a hormonal microenvironment that promotes cancer growth, while pancreatic cancer involves a fibrotic stroma that complicates treatment. These differences affect how cancers develop, progress, and respond to the therapies.
So, the organ's environment is crucial in shaping cancer's behavior. But how does this organ specific microenvironment impact how cancer cells grow and respond to treatment?
Each organ's tumor microenvironment, that is TME, is unique. In breast cancer, the hormonal environment drives tumor growth, while in pancreatic cancer, a dense trauma makes it harder for treatments to reach the tumor. Some cancers, like lung cancer, can manipulate the immune environment to evade detection. These interactions determine how a tumor behaves and how it responds to the treatment, which is why therapies need to be personalized.
It sounds like the tumor's environment really dictates how the cancer progresses. So let's dive into how developmental origins influence cancer specific, rather organ specific cancers. Aditi, could you explain how BRCA mutations relate to breast and ovarian cancer?
Certainly, Ritika. BRCA1 and BRCA2 mutations are linked to breast and ovarian cancers because these tissues frequently undergo cell division and DNA repair. When these genes are mutated, the cells accumulate DNA damage, increasing the risk of cancer. The loss of BRCA function makes these tissues more vulnerable to mutations, contributing to cancer development, specifically in the breast and ovaries. Moreover, these cancers show specific molecular features, making them more sensitive to therapies like PARP inhibitors.
So it's not just the mutation itself, but also the tissue's role in DNA repair that drives cancer's risk in these organs. Before we close, Aditi, what should our listeners remember about the role of organ specific behavior in cancer treatment?
So, the main takeaway is that the tissue context really matters. The organ's microenvironment and molecular profile determine how the cancer behaves and respond to treatment. Tailoring therapies to these factors can improve outcomes for patients with organ-specific cancers.
Thank you for these insightful points, Aditi. And thank you all for tuning in. If you enjoyed this episode, be sure to share and subscribe for more deep dives into cancer biology. Stay curious and keep exploring.